How can we know if this water is pure? There are two methods we can apply in this. Either use heating curve or cooling curve. What is a heating curve and what is a cooling curve? Well, let me explain. A heating curve is a graph of temperature against time obtained when a solid is heated until it changes to a gas. When a solid is heated, it undergoes two major transitions to become a gas. Do you remember what these are? Good. The first one is called melting. It is the transition from solid phase to liquid phase. The second one is vaporization. It is also called evaporation. It is the transition from liquid to gas.
When pure ice is heated, its temperature starts rising until it gets to 0 degrees Celsius. But something dramatic happens here. You know what it is? Well, the temperature stays the same until all ice has melted. Then the temperature rises gradually throughout the liquid phase. When it reaches 100 degrees Celsius, once again the temperature remains constant until all the liquid has evaporated. Then the temperature now picks up and rises gradually. Plotting a graph of changing temperature against changing time reveals this heating curve. Heating curves of pure substances have sharp melting points and boiling points. This is because the energy pumped into the solid is used up to break bonds, binding up particles in the solid. Similarly, the energy pumped in the liquid is also used to break bonds to make the particles free in the gas phase. Similarly, in the cooling curve, there are sharp condensation points and freezing points. If we add impurities to the heating curve, then we realize that the melting point is depressed or it is lowered, while the boiling point is elevated or it is raised. Those are effects of impurities on the heating, on the boiling point and the melting point. And that is the way we can be able to know whether a liquid liquid is pure or not pure. If it is pure, it boils sharply at a certain known or predetermined temperature. Same case to melting. If we introduce impurities to the cooling curve, similarly it follows the same trend as the heating curve. We find that the condensation point or the impure water will condense at a higher temperature and it will freeze at a lower temperature than pure water. How can we apply the knowledge of criteria of purity in real life? Well, in countries that experience winter covers the roads, making it difficult and risky to move, especially with vehicles. Hitting all the ice on the roads can be practically difficult and expensive. For this reason, salt is normally applied on the roads. That helps to melt the ice when the temperature is way below 0 degrees Celsius. No heating is required and the ice melts, and this improves the passability in the roads. What about where can we apply impurities in boiling point? I would also like to hear your views on this. Please share your ideas and thoughts in the comment section below, and don't also forget to like and subscribe to this channel and share it with your friends so that you can boost us, we keep growing and we keep learning together. Thank you for staying to the end of this video, and from Science Tips, until we meet in the next tutorial, we wish you